All right, hello everybody. Here is your video key for your group test for PA.1 to PA.6. First, we're looking at domain and range. So domain is the smallest x value you see on the graph up until the biggest x value that you see on the graph. Remember that when we have a connected graph, so we have a line connecting every point, or a curve connecting every point like this, as opposed to this where it's just a bunch of points. These two up here are where you have to use interval notation because there's infinitely many points along this line. There's points everywhere. So every single x value is used starting with this one and ending with this one. So this x value at this point is -1, 2, 3, 4, 5. And this is where you use a bracket, -5, up until this x value, which is 3. And we're using a bracket on both numbers because both those numbers are used. You use a parenthesis if this were to be a whole, because that means that point doesn't actually exist, but everything really close to that point exists, like as close as you can get. If it were like that, that is when you would use a parenthesis. That's not what's going on here, though, so we're going to use a bracket. Our range, we do the same way, except we're looking at the highest or lowest y value, which is at this point, and then as high as the graph goes this way, which is that point, so the y value. So this y value is -1, 2, 3, 4, 5, 6. So -6 until a y value of 1, 2, 3, 4. And there you have it. Is the relation a function? We will just say yes, it is, because it passes the vertical line test. Our domain over here. So now our smallest x value with these arrows, this graph is going left forever. And so our domain goes to -infinity, always a parenthesis, an open bracket on -infinity or +infinity. And then the largest x value, so as far as the graph goes to the right, is this x value, which is 2. And then always a bracket on 2. Our range, this graph is actually going to go down forever and up forever as it continues to the left. And so our range is just -infinity to infinity. And then is this relation a function? No, it is not, because it fails the vertical line test. And you can just say VLT if you want vertical line test. On 3 and 4, this is where we just list the x and y values of the points we see, because they're like over here, -5 and -3. There is no value at -4. There's nothing going on there because there's not a line connecting these points. And so that's where you just list them all out as opposed to using interval notation. So coming over to number 3, you should list them from smallest number to biggest number, and you don't need to write ones that repeat. And this is where you use a squiggly bracket. So -9, -8, 2, and 1. And then for our range, again, just the y values that we see. And once again, though, you go smallest number, which is -8, -6, -5, 0, and 5. And then this relation is not a function because for one input, of -8, we'll say, so that's the input we're looking at. Right here, it occurs twice. So for one input of -8, there are 2 different y values, or 2 different outputs. There are 2 different outputs. You can say x and y instead of outputs, inputs. Up to you. Okay, now coming over here, our domain is just all the x values that we see. That one, that one, that one, that one, that one, and that one. A little easier to write them in order from a graph because they're already going to be in order from left to right. -5, -3, 1, 2, 6, and 8. Notice how on this graph we do have repeating y values right here, but that doesn't mean anything in terms of being a function or anything like that. So We don't have to worry about that. And now for our range, list all the y values, which are all the numbers I'm highlighting in purple. And again, a squiggly bracket because it's only the numbers we're listing, no numbers in between these numbers work. And now just go start with your bottom one and work your way up if you want to write them in ascending order. So -2, 0, 2, 4, which repeats, so we don't need to write it twice, and then 7. And this is a function. Now, since it's a graph, you can say it passes the vertical line test, or you can say there are no, for every x value, there's only one y value. Okay, so using function notation now, a of 4 means we're plugging 4 in for x into this function. And so it's just 3 times 4 squared plus 5 times 4, which is 16 times 3 is 48 plus 20, which is 68. C of 10. So we're taking 10 and plugging it into function C over here for x. All of these problems, this is your x value. Plug it in, plug it in, plug it in for x, plug it in for x, plug it in for x. This is the only one where we're finding x, so this is a y value. So we're going to set this equation equal to y when we get there. But going back to number 6, it's just 4 times 10 plus 5, which is 45. That's not a square or a rectangle. Oh my gosh. One more time. Woohoo. All right. And then b of 11. So plug in 11 right here. And we get square root of 11 minus 2, which is the square root of 9, which is 3. If this number happened to not be a perfect square, like a number you know the square root of, you can just leave it, like if it was 15 underneath, you can just write square root of 15. That would be fine for now. A of -2, be careful with negatives, especially when you're plugging it into x squared. A lot of times people will type this wrong on a calculator, but this is going to be 3 times -2 squared in parentheses plus 5 times -2. So you square this number first, making it positive, and then times 3 gives you 12. So it's 12 minus 10, which is 2. Number 9, this is where you're taking 4x plus 5 and setting it equal to 29. And solve. Subtract 5. So you get 24, and divide both sides by 4, and you get x equals 6. And the last one, b of 27. Again, we're plugging it into the function b right here for x. And so it's the square root of 27 minus 2, which is the square root of 25, which is 5. And there you go. 11 through 14 is the same thing, except from a graph. So I've given you x, find y, x, find y, x, find y. Given you y, find x. Remember, this means fancy pants way of saying y equals -9. So when x is -5, come over to your graph, find when x is -5 right here, tell me the y value, and it looks like it is 7. So you get 7. F of 2, same thing, find when x is 2 right here, and y is 2. And then f of 9, again, that means x is 9, find your y value, and it's 9. And then finally, this is the y value. So find when y equals -9. This could have more than one answer. This graph doesn't, but it could, in theory. And our x is -2 and y is -9. So x equals -2 on this one. Okay, now we're just describing transformations in words. Anything on the inside of the parentheses goes left or right. Since it's plus, it's going left. So this is left 4, down 5. Whoops, fix that in a second. Left 4, down 5. There you go. And then this is a reflection over the x-axis. and this means it goes right 2. So we have a reflection over x-axis. And then right 2. That's it for those. All right, on 17, just be careful on this one. Pay attention to the scale. This is counting by halves, so from here to here, we've only gone up 2. Now when it says find g of x in terms of f of x, that means you're turning f into g. So what do you do to f to get to g? And you have to go up 2. So up 2 is just take the original function, f of x, and add 2. And that's it. On 18, let's pick out the important information here. We're taking x squared, and we're going to go left 5, and we're going to go down 2, and then it's reflected over the x-axis. And so starting with x squared, we got to do these transformations. So we'll call it g of x is equal to, since it's going left, that has to go inside the parentheses that we don't have yet because the original problem doesn't have it. But going left is x, and then plus 5 to go left, squared. Down 2 is a minus 2 at the end, and reflected over the x-axis is putting a negative in front right here. And then, so that is when it's in as an expression. So that's as an expression written in black. And then we need function notation. And that's where you write it in a more generic way where it applies to all graphs ever. So g of x equals, so instead of using squared, we're going to use just generically f. So it's negative, keep the colors the same, f of x plus 5, and then minus 2 at the end. And so this notation means to get a new graph from whatever's graphed, it doesn't matter what it is. In this case, it's x squared, but it could be any graph in the world. Take any graph, and if you write it like this, it means take the original graph, move it left 5, flip it over the x-axis, and then move it down 2. Okay, on 19, again, very wordy, but a lot of the words aren't that meaningful, really. We're starting with this function, 2x squared, and all we're doing is stretching vertically by 3. That's it. And so to stretch anything by any number, you just multiply the original function by that number. So we're going to take a new function, g of x, and it's equal to the old function, 2x squared, and then just multiply that by 3. And that's all you have to do. Make that 3 a little nicer. And if you really wanted to, you could write it like this. You can multiply the 3 and the 2 to get 6x squared. So either way you want to write it is fine. And then finally for the bonus, similar stuff here. We're taking some function f and doing some transformations and calling the new function g. So g of x is equal to, let's get the key information here. We're going to go up 2, vertically stretched by 4, reflected over the x and y axis, horizontally shrunk by a factor of 1/2. All right, so up 2, take the original function, f of x, and you're going to have at the very end, plus 2, outside of the parentheses. Vertically stretched by 4 means we're going to put a 4 right there, multiply by 4. Reflected over the x-axis means you got to have a negative right in front of everything. And if it's reflected over the y-axis, you got to have a negative in front of the x on the inside. That's the stuff we didn't really do, was the horizontal reflections or the shrinks, but that's why this is a bonus question. And then to do the horizontal shrink by a factor of 1/2, this is where it gets weird. It's actually a 2 in there, so it's the reciprocal of this number that goes there. So if it was a horizontal stretch by a factor of 5, you would put a 1/5 right there instead. And that's it. Study hard. I know you guys can do great.